In this video, I will be demonstrating how to create a confidence interval using the TI-84 calculator when dealing with polling data and specifically with proportions. We're going to do an example. In this example, we're interested in the type of car, whether it's an American car or a foreign car, is driven by more college students. There was a study conducted to estimate the proportion of college students who drive a foreign car. A random sample of 160 students were asked which type of car they drove. 96 students sampled responded that they drive a foreign car. The first thing we're asked to do is to calculate a 95% confidence interval for the proportion of the population proportion of college students who drive a foreign car. So there's really no way to know the population proportion. In order to know that number, we would have to be able to sample all college students, which is not practical. It's not realistic. So what we're going to do instead is create a confidence interval. Rather than give a single estimate, a single number estimate, what's called a point estimate, we're going to use the calculator and we're going to come up with an interval of values. Now, to do a problem like this, really what we need to do is know what buttons to push on the calculator. The stat key is the key we want to focus on here. So if I press the stat key, this takes me to a lot of different options on the calculator, and we'll come back to a couple of these in the future. But for now, let's look at just tests. So I press stat, arrow to the right twice to tests, and these are where I can find the options for creating confidence intervals. So we have the Z interval, we have the T interval, 2 sample Z, 2 sample T. This is a 1 proportion Z interval. So anytime you're dealing with any kind of polling data or any kind of a situation where the goal is to estimate a proportion or like a percentage, this is the one that we want to use, the 1 prop Z interval, choice A on the calculator. And there are just a few things we have to enter here. First thing is the X value. Now the X value in this case is the number of college students who drive foreign cars. That's that's 96. And then the sample size is given right here, 160. Oops. $160 for the sample size. Confidence level, well, we can adjust this. If we increase the confidence level, the width of the interval will get wider. If we decrease the confidence level, the width of the interval will get narrower. 95% is a very common level of confidence, and this is what the problem asks for as well. So what we have here is a range of values. So essentially, this interval ranges from 52% to 68% roughly. And this is the point estimate that I talk about in the corresponding reading assignment. The point estimate, it's a p hat is what we call this, and that's the sample proportion. And again, that's a notational thing. That circumflex over the p means sample proportion notationally. And so 60% of the sample of the students sampled own foreign cars or drive foreign cars. But keep in mind that our confidence in that single number estimate is very low. This is like the BB trying to capture the fly. Rather than using the BB, we want this fly swatter, which is an interval or a range of values. So we're 95% confident that the true proportion is somewhere between 52% and 67 or 68%. So let me write this down. Often we abbreviate confidence interval with CI, and I would say that the true proportion is somewhere between 52% and 68%. Now, this is part B. This is part A. So part B asks, based on the confidence interval, does it appear that foreign cars are driven more among college students? And we're asked to explain this. Well, what we would conclude here is that we are confident that more than half, right, more than 50% of college students drive foreign cars. So the entire interval's to the right of 50%. So our estimate is clearly greater than 50%. So the answer I would say to part B is yes. And then finally, we're asked, is the following statement correct? If repeated samples of 160 college students are obtained, we would expect 95% of the resulting samples to have a sample proportion who drive a foreign car that falls in the interval computed in part A. That's basically the correct idea. This is also referred to as the frequentist interpretation. Interpretation. I think I'm spelling that right. And notice that with the frequentist interpretation, there's an implication of frequency here. And this frequency I refer to as the capture rate. That's how I like to think about it. And what does that mean? Well, what it means is that if I make, as an example, if I were going to become a professional statistician, and say I work for an organization that does these types of confidence intervals all the time, then I would, if I were creating all of these confidence intervals at 95% confidence, it means every once in a while, well, let me be more specific. I expect one of every 20 to not capture or capture the parameter value of interest. In this case, the parameter of interest is the population proportion. So did we capture the proportion with this confidence interval? Most likely. Do we know if we captured it? No, we don't know that. We do not know if we captured it for sure. I'm 95% confident. And the way I think about that is if I create these confidence intervals all the time, one time out of 20 I'll miss. Which time? I don't know. It's like rolling a 20-sided die or something like that. I roll a 20-sided die and say one is a miss. Well, every once in a while the one's going to come up. Am I confident it's going to come up? Not really. One time out of 20 doesn't happen that often. So we miss at 95% confidence, we miss the parameter one time out of 20. On any particular interval estimate, we don't know if we captured or missed. All we can really say for sure is that we're 95% confident that we have captured that parameter value. Well, I hope that makes sense. I hope that helps you with the homework one of the homework problems. I'll see you next time.